Okay, guys, so we're going to find the 3 by 3 of a determinant here. And our book actually just gives this one formula that I'm going to highlight right here. Um, and pretty much tells you to take any matrix and break it down like this. So if we had a matrix written this way, 3 by 3, then we would take A, this first row, first column, multiply it by EFHI. And notice this is this bottom square. All right, and remember this straight bar notation means the determinant of just that. So we would actually, getting all kind of stuff on here, do A, and then to find the determinant, written like this 2 by 2, we do the diagonal EI minus the other diagonal HF. So that would be that first one. Okay, I'm going to erase some of the stuff I have on here. Then you take B, right, what they have here. So we do minus B, which is right there in this matrix. And you're multiplying it by DFGI. And I want you to notice where these are. So if I take the row and column, B's in this first row, and I cross that out, I'm left with DGFI. Now, I didn't do that initially for A, but the same thing, if I had crossed out the row and column that A is in, I would have got this, it's called a minor, right? Little determinant left. So that's how these little minors are made over here. So that DFGI, we would then find the determinant. So DI minus GF. And then the last one, C, and we can remember how we get these four values, because C is right over here in the matrix. We're going to cross out the row and the column, and we're left with those four D, E, G, H. And we would do DH for the diagonal minus GE. Okay, so that's kind of, where the formula comes from. This really comes from Gaussian elimination and solving through if we had to. But this will give us the determinant of a 3 by 3, which you can use, we'll see later on, for solving systems, finding inverses. We won't do for more than 2 by 2s, but that can help you out with 3 by 3s. So we're going to find the inverse of this 3 by 3 matrix here using that formula up top. So I'm going to take, or sorry, I said find the inverse, but we're actually going to find the determinant. So the first thing I'm going to take is the first entry, -3. And to find that little minor, I'm going to cross out the row and column, and I'm left with -1, 2, 4, 0. So I'm just going to write it out. This is the only one I'm going to write it out for. Right? So that would be that first one. Now, tricky thing to remember is we need to subtract for the next one. So minus taking this second entry 2, I cross out that row and column the 2 is in, I'm left with the numbers that I'll need to fill in this determinant. Okay, I'm going to do a little erasing over here. And then lastly, we'll have 4. We add the last one. Cross out the row and column. 1, -1, -1, 4. All right, and then go solving through. So I'm going to multiply to find my actual determinant. So this would be -1 times 0 minus 4 times 2. Remember, we're finding the determinants of these little 2 by 2s. So I'm going to go through and write those out. This will be 1 times 0 minus -1 times 2, so that'll be plus 2. And lastly, 1 times 4 minus -1 times -1 is a positive 1. And finally, we're going to simplify one more time. So we should get 24 minus 4 plus 12, which I think works out to be 32. I want to check with my answer key here as we go. See if I didn't do anything silly. And I think we look good. So that would be finding the determinant. That's the determinant of this matrix A.